Hello everyone. Today we will be beginning a review of the ACT standardized test, and in particular we will be reviewing ACT math problems. So for those of you who don't know, ACT math problems do not require a significant understanding of mathematics beyond what is required for a 10th or 11th grade level, typically. However, what tricks a lot of students is that there is a form of logic that is needed for most ACT problems that require 2, 3, or sometimes more steps in order to solve the problem, using a mathematical logic that is present in regular high school courses, but in multiple steps, which often tricks a lot of students into thinking that the answer is more complex or more simple than it actually is, and preventing you from getting the right answer. So today we will be looking at one ACT problem, which is fairly simple and has to do with geometry and algebra, and seeing if we can solve it. So here we have a square with another square inside, and we have the labeled distances or sizes of the sides. The small square has an x for one side, and naturally the other side is also x. And what the problem is asking us is that each side of the smaller square in the figure below is x inches long, which is exactly what we see in the figure. The small square is x squared in area. And each side of the larger square is c inches longer than a side of the smaller square. So this segment right here is c inches long, and naturally this segment right here is also c inches long, since the gray area is also a square, including the smaller white square. The area of the larger square is how many square inches greater than the area of the smaller square, and this is the most important sentence right here, because it describes exactly what the question is looking for. So in other words, we don't want the area of the entire large square. What we want is the gray area, essentially. And the best way to get the area of the gray space is to find the area of the total large square and then subtract the white area or the smaller square from that. So what we can do is first determine what exactly is the area of the larger square before we can subtract anything from it. And we know that one side of the large square is of the length x plus c. And since the area of a square is one side squared, all we have to do to get the area is x plus c squared, which we can then distribute as such. Or as many students might write it as x squared plus 2xc plus c squared. Now, from our initial analysis of the problem, we understand that the area of the smaller square, which we will label as a1, is just x squared. And this right here is a2, the larger square. And again, since what we want is the larger square minus the smaller square, all we have to do is perform a2 minus a1, which will simply be x squared plus 2xc plus c squared minus x squared. And simplifying this, we can simply cancel out the x squared, and we will be left with 2xc plus c squared, which will be our final answer. One of the trick answers here is letter I, which, if you notice, is where we left off when we found the area of the larger square. And this answer choice is there in an attempt to trick students who might stop solving the problem after they have found the area of the larger square and have forgotten to complete the final step, which is to remove the area of the smaller square.